models need to be updated as new evidence is discovered and scientific understanding develops. A good example of this development and changing of models can be found in atomic theory. The idea that matter is made up of tiny, indivisible particles called atoms has been around for thousands of years. But it wasn't until the 19th century that scientists began to develop a more detailed and accurate model of the atom. One of the key figures in this development was John Dalton, an English chemist who proposed the first modern atomic theory in the early 1800s. According to Dalton, atoms were tiny, indestructible spheres that combined in simple ratios to form compounds. This model helped to explain many of the chemical reactions that scientists were observing at the time. But as technology advanced and new experiments were conducted, it became clear that Dalton's model was too simplistic. In the late 19th century, J.J. Thomson discovered the electron, a negatively charged particle that is much smaller than an atom. This led to the development of the plum pudding model of the atom, in which electrons were thought to be embedded in a positively charged sphere. However, this model also had its limitations. In 1911, Ernest Rutherford conducted the famous gold foil experiment, in which he bombarded a thin sheet of gold with alpha particles. To his surprise, some of the particles were deflected at large angles, suggesting that the atom was mostly empty space with a dense, positively charged nucleus at its center. This discovery led to the development of the modern atomic model, proposed by Niels Bohr in 1913. According to Bohr, electrons orbit the nucleus in specific energy levels, or shells, and can jump between these levels by absorbing or emitting energy. This model helped to explain the behavior of atoms in a way that previous models could not. Since then, our understanding of the atom has continued to evolve. Scientists have discovered subatomic particles like protons and neutrons, and have developed even more sophisticated models of the atom based on quantum mechanics. The evolution of atomic theory is a powerful example of how scientific thinking can lead to a deeper understanding of the natural world. By constantly questioning, experimenting, and refining our models, we can uncover the hidden truths that lie at the heart of the universe. And who knows what new discoveries and insights the future may hold?